ammonium carbonate, you can see the whole morphology is completely cross-linked. So this is the kind of morphology we actually desire, because we want these because these pores, they help for the effective wound exudate absorption. They are required for proper air circulation on the wound. So this kind of, so this is our patent, where we are using ammonium carbonate for for actually creating the bio-inspired cross-linking of polydopamine. So this is a patent technology. Then we have also checked that whether this polydopamine, it is safe for the skin cells. So you can see here, these are basically the confocal images of the cells, dermal cells, basically dermal fibroblast. And we find that this cross linkers, they are absolutely safe on the dermal cells. The cells are very happy with this material. So then what we did, now here we have already optimized the material, that is gelatin, which is cross-linked with the polydopamine. And now we need an antimicrobial component. So what we added as antimicrobial component are the antibiotics. So we used different antibiotics like vancomycin, tobramycin, caspofungin. So these are, for example, the vancomycin, it is effective against gram positive. Tobra is against gram negative. Caspofungin is basically for fungus. So we actually use different kind of antibiotics, and with polydopamine and gelatin, we included these antibiotic in the dressings. And finally, this is the antimicrobial nanofibers we have designed. So these are the different antibiotics, as I have mentioned, we have incorporated. And in the bracket, and this is basically the number of OH groups each antibiotic has. This 5, it has 6, it has 7. So we actually made some correlation also with the number of functional groups. So this is the nanofibers we have designed with different antibiotics. And this is basically, the small pictures in the inset of the SCM pictures. You can see that this is basically the antimicrobial, result. So what actually it indicates, I will just explain in briefly. This in the center, you can see this area is very clean. Outside there's this yellow component is there. So now what is this yellow component? This is basically bacteria. So what we did, we grow the bacteria, we put our dressings in the middle. After 24 hours, if we have this clean zone, that means that material is antimicrobial in nature. And if that material is not antimicrobial, this bacteria will grow even on the material itself. So you can see here that in this case, even in this case, and in this case also, we got a very clean zone of inhibition. This is called zone of inhibition. So that means all these dressings, they are very effective in killing the microbes. So now the relation I mentioned with you, that number of hydroxy groups and the effectiveness of these dressings. You can see here this daptomycin, DAP, after 1 days, its antimicrobial properties lost. For polymyxin B, which has 2 hydroxy groups, after 4 days, the antimicrobial activity is lost. But the antibiotics which have more number of functional groups like amphotericin B, vancomycin, tobramycin, which have more number of hydroxyl groups, it can actually show the antimicrobial effectiveness even for 20 days. So that means more is the number of, hydroxy groups. More is the interaction of these antibiotics with the polydopamine and the gelatin. More slowly it will release out from the dressings, and more is the durability of these wound dressings. So why we have done this? Because the commercially available silver based dressings, they have the effectiveness for 15 days, but these dressings which we are using, it has the effectiveness for around 20 days. So that is because of the more enriched hydroxy surface. Now, this dressings we have actually checked on the animals also, that whether it is, when we are using it outside on the cells, it is called in vitro testing. When we are using on the animal, it is called as in vivo testing. So once our dressings are ready, we have tested it on animals, and this animal is basically a pig, because the skin of the pig is more resembled with our skin. So that is why the results will be more relevant if we will try these dressings on the pig skin. So you can see here, these are our dressings, which are actually cut around 4 centimeter diameter, because our wound is of that area. You can see here, this is the day zero burn wounds. This is second degree partial thickness burn wounds, which we have created. And after the creation of the wounds, we have actually put these dressings. This is our vancomycin, gelatin, and polydopamine dressings, and down is this is the commercially available silver based dressing. So we compared it with the commercially available dressing, and this is basically the nanofiber dressing after removing from the wound. And you can see even after removal, the nanofibrous porous morphology is still intact. This is basically the progression or the treatment or the healing of the wound. You can see that after day 46, the wound is quite dry and it is quite healed. And if we see the graph, you can see here that the wound closure, if you see that vancomycin wound closure is much better as compared to the silver based wound dressing material. So that means these dressings are, if not better, it is performing equally good as the silver based dressing which is in the market. So right now, these dressings, right now, they are actually under clinical trials. Clinical trials means we have already tested it on pig, but it has to be tested on humans also. Then only the FDA approval and all can be made and it can be utilized for humans. So clinical trial is right now in progress. We have all, instead of using antibiotics as antimicrobials, we have also tried cationic polymers as antimicrobial in these dressings. And why we have also tried cationic polymers, because many clinicians, they are concerned that for topical application it is better to avoid antibiotics, because again the reason I mentioned in my earlier slide, that antibiotic, it generate resistance in the microorganisms, so it's better not to use antibiotics and replace them with some other antimicrobials. So we have used some cationic polymers. Now which cationic polymer we should use? So we have actually make a list that which are the very effective cationic polymers. So this is a list we have prepared, and we start investigating all these polymers. And first of all, what we did, we basically checked the antimicrobial potential of these, all these cationic polymers, and we have also checked its cytotoxicity for dermal fibroblast cells. As I have mentioned, that the antimicrobial component, it should kill the microbes, but at the same time, it should not kill the skin cells. So from these results, I will just tell you the conclusion that we find two polymers. One is the epsilon polylysine and another is the linear polyethylene imine, which are very selective. That means they kill the bacteria, but they don't kill the human cells. So they are very selective. So we from this result we have taken these two polymers and investigated them further. One second. I think there is some problem. I will just load it again.